get things to do things for you, well, you better treat them nicely. This is especially the case when it comes to enzymes, which are typically proteins that will carry out biochemical tasks. They speed up reactions. Every different enzymes will speed up different reactions. They can be doing anything from polymerization, chaining together DNA letters, proteases like cutting up proteins, various things. And we use enzymes a lot in the lab, especially there's a bunch of like molecular biology enzymes like NEB, New England Biolabs. I do not work for them or anything, but they sell like every sort of enzyme under the sun. And we use them a lot when we're doing various experiments, but we need to make sure that we keep them active. And to do this, we need to treat them with TLC and ice. So basically, enzymes, you want to keep them cold at all times, and you typically want to add the enzyme as the last thing that you add in a reaction. Often the reaction is going to have a bunch of different components, and you're going to add the enzyme last. And when you add the enzyme, there's a couple different things to keep in mind because they're often really viscous, really syrupy. They're basically frozen in a solution that contains a lot of glycerol typically. Glycerol is a cryoprotectant, which is going to prevent it from freezing. So this prevents like the ice crystals from forming within that enzyme and messing up the enzyme activity, which is great. But it's also really viscous, and so then when you go to pipette it, it might get stuck in the tip, and so you want to pipette it really slowly up and really slowly down and make sure that you're watching as you go, and typically a really tiny volume, so we'll talk a little bit more about why making master mixes and that sort of thing. But let's step back. So we have these enzymes. When you get one of these enzyme tubes, the first thing that you want to do is spin it down to collect all of the enzyme to the bottom. So when you get them in the mail, they're often shipped on dry ice, or at least those like gel ice packs. But sometimes like the tubes will be like upside down or something like that, and the enzyme can be all over it. So you want to just give it like a quick pulse spin in the microcentrifuge to draw everything to the bottom. This is a couple functions. One is that the more surface area that's exposed to the tube, the more that can potentially get stuck to the tube, which means the less enzyme for you. Also, you can have evaporation the more that's exposed to the air. Also, when you open the tube, if it's on the kit lid, well, now you've like contaminated things or it splashes all over. So basically, always a good idea to spin things down first. Another thing is you want to look at the expiration date. If it's on the tube and the lot number, sometimes it comes, if something comes to the kit especially, it's going to be on like the box rather than the tube itself. And you want to have that information on the tube itself so you can refer back to it later. And so I typically write the date that I got something, and keep it on the tube and then freeze it. And then that way you can look back and see if like you had a problem with something or whatever. What was the batch I used? Or how old is this enzyme? Note that the expiration dates, you can typically use them way past their expiration date, but if it's something like a critical sample, you don't want to risk it, but especially for like restriction enzymes and things. I've used them years and years and years past their expiration date, and they seem to be fine. But if it's something critical, you might want to do like a test. Maybe if you have a newer one and an older one, you can do like a head-to-head comparison. But some of these enzymes are so cheap, it's probably just cheaper to buy a new one if you're concerned. So I've been like playing around with this tube, but this is not an enzyme. If it was an enzyme, I would not be doing this. So you never want to be like holding them from the bottom because then you're going to warm them up. You want to keep these enzymes on ice as much as possible to prevent any sort of denaturation or like them unfolding or getting uncomfy or any sort of protease activity or something like that. If there's some contaminated in there, you don't want it to be chewing up your enzyme. And you don't want your enzyme to be trying to do things, so typically they're not very active at this cold temperature, and so we want to keep them in that like hibernation state, be happy. Typically, these are stored at like -20, so just like in your normal freezer. Sometimes they need to be stored at -80. When you get a tube or a box or something, it should say like on the box, it should say like where to store it at, and make sure you follow that. Okay, so when you're working with them, we typically store them. So we have these like little freezer boxes, these little like ice trays. They look kind of like a thing you might take camping, but they're like a solid brick. This is going to keep things cold even when you take the box out, at least for a while. And this is really helpful if you're trying to dig through different enzymes. You don't want to be like rummaging around in the cardboard box, getting all these enzymes hot and then them not working. So you want to keep them in that box. This also prevents you from having to keep the freezer door open when you're digging through things. And it also helps you find things because you have the tubes facing up. And so, yeah, also sometimes they don't have a name on the lid, which is stupid. So write the name of the enzyme on the lid, and that will help you prevent digging around as well. We also have these like little carriers. These are good for transporting the enzyme. So when you take it out of the box and then to your bench or whatever, you typically don't want to get it until you're at the very end when you're ready to add it. So we want to add the enzyme last in our reaction most of the time. This is for a few different reasons. One is that we want to make sure that we have all the conditions just perfect for the enzyme before we add it. We also want to make sure that the enzyme isn't going to do any weird stuff when we add it. So basically sometimes enzymes, if they don't have all the right reagents to do what they what you want them to do, they'll start doing other things. So the key thing to make in mind is that enzymes catalyze reactions, which means that they speed up both the forward and the reverse directions of a reaction. So if you don't give it what it needs to go forward, it can sometimes go backwards. Things like that you might encounter with like polynucleotide kinase, things like this. But sometimes we can take advantage of that. But anyway, it can also just like act weird if you like have side activities, if there's only like certain things that are there. So you want to add it last. Adding it last also is going to help you better keep control of your incubation time. So typically when you add one of these enzymes, you then have some sort of incubation step at a specific temperature for a specific time. And you want to make sure that your time is actually what you think your time is, which means that if you add your enzyme in the beginning and then you're still preparing things, well, now your time is going, oh, what was that time? When you start your timer, it's been a while, and your enzyme might have been at a weird temperature. So you want to add the enzyme last. When you're adding these, so basically you want to get everything ready and then add it. A note about things getting ready is that they often come with like a buffer. And the buffers typically, they come with like a mil buffer or something. Often like way more buffer than you actually need. But the bottom line is it's going to take a while to thaw. So your enzyme, you don't need to worry about it thawing typically because it's in glycerol, and it's so much glycerol that it's not actually frozen. It's just like in this like gooiness state. And so you don't need to worry about it. So you can get it like right before you want to add it. But for the buffer, it's going to take a while to thaw, and so you want to get it out to thaw. Typically you can just thaw it at room temperature, even like heat it up a little, especially if the reaction's done at a higher temperature. But don't heat it up too much, then your temperature is hot when you add things. Basically, yeah, just make sure you get this out ahead of time, as well as there's often a bunch of other reagents that you need to add. So typically in one of these reactions, you might have to add, like say ATP, you might have to add some magnesium or something like that. There'll be different tubes that'll come in your kit, or they'll direct you to add different things, and you need to add each of these to a reaction. And typically you'll have like you'll need this much, like 1 microliter of this per reaction, 1 microliter of this, 5 microliters of this, and it can get really tedious to have to pipette out each of those in each reaction. Plus then you could have, if you have like multiple samples, plus you then could have variation between your samples. Additionally, when you're pipetting really small volumes, like little tiny errors make a big difference, because it's like percentage-wise, like drop in an ocean versus drop in a teaspoon. And so it's more accurate and better for all these reasons to typically make a master mix, which is basically you make put all that generic stuff together, and then each of the unique samples, then you add the generic stuff, like one reaction's worth of the generic stuff to each sample. When you're making one of these master mixes, I typically make like at least 1.5 more than I need. So this way I have, if something goes wrong when I'm setting up one of the sample reactions, then I have a backup. And you also always want a little bit of extra. So if I just did one extra, I wouldn't have enough for a full backup probably, because every time you pipette, you lose a little bit. The master mixes are also really helpful when you're doing things with enzymes, because typically when you're adding the enzyme, you're adding a really tiny amount. So often this is just like 0.5 of a microliter per reaction. And that's going to be really, really, really hard to pipette accurately, even with like a P2, so a 2 microliter pipette. So you don't want to be pipetting that small of a volume. Instead, if you have a master mix, so say you're making enough for like 10 reactions, well now 0.5 times 10, you're pipetting 5 microliters, which you can do much more accurately. So when you're pipetting the enzyme, remember we're adding it last. So you're adding a small amount though, and you want to make sure that everything is mixed well. So when you're adding it, I typically, it's going to be really viscous, remember? So you want to, when you're pipetting it, you want to put your tip just like right under the surface. If you put it too far in, it's all goopy and it's going to stick to the outside of the pipette. And then when you draw up, you're going to have excess on the sides of your pipette tip. And so you don't want that happening, because then you're pipetting more than you really intend to pipette. So you also want to make sure that when you're watching it actually go up the tube and you don't pull out too quickly or you're going to get bubbles. More on this in other posts, but you don't want it to like kind of like jump up, or you don't want it to, you want to make sure that it stops moving upwards before you pull out. And then once you pull out, you want to make sure that when you put it in, you go really, really slowly and it all gets out. To help with this too, like when you then pipette in, do it right under the surface again. And this will gonna prevent like anything that was on the outside of the tip from getting into it. Doing it right there at the surface too, you want to be like in the liquid or onto the side of the container. That's gonna allow the surface tension to help kind of like draw things out of the pipette to make sure that it all comes out. Typically it's gonna, since it's so like it has all that glycerol and stuff, it's gonna sink to the bottom and you'll see this kind of like wiggly squiggly thing coming down. Typically what I like to do is I like to go up and down a few times and wash out the bottom of the tip so all of that can get out. But that's not really gonna mix the solution. In order to mix the solution, you can then take like a P1000, mix up and down. Again, you don't want to make bubbles, so you don't go out and where you get air. Just go up until you almost get air, and then just go up and down sometimes. You can also do like the finger flick, the finger vortex. That's really good, but don't do an actual vortex. That's going to be too harsh on your enzyme, so don't do that. Once you do that, then you can then add your master mix to all of the different samples. Sometimes there are protocols where it says like don't make a master mix, so then don't do it. But otherwise, it's pretty good. It's basically do it. Other times, also another thing that can prevent you from having to pipette small volumes is sometimes the reactions will come with like a dilution buffer, where they actually have you dilute the restriction or dilute the enzyme before you actually use it in this buffer, and that will help you not have to pipette really small volumes. So you might be wondering, why don't they just sell it to you more dilute? Well, it's better for these enzymes to be at a more concentrated solution, and it keeps them happier to be more crowded, like they're used to being in a cellular environment where things are more crowded, so having them more crowded makes them happier, and you also have less risk of losing things to the sides of the tube and various things like that. So there are reasons why they do it. It's not just to annoy you or make you inaccurate or anything like that. In terms of how much to add, often these are in terms of units, and so units is, don't get me started on units, I have a whole post on that, but basically it's whatever they say it is. So it might be like one unit is enough to digest like so and so nanograms in 1 hour in these conditions or whatever. Basically, they just need to tell you what it is. But the definition of a unit can vary from company to company, and so can the concentration of the enzyme. So you want to make sure that when it says like add this many units, if you're just going off a protocol which says add this many microliters, make sure that the concentrations are the same in these protocols, or else like calculate accordingly so that you're adding the right amount of units. Don't freak out if you don't use all of the tubes that they give you. So sometimes like you're using your own buffer or something, and so you don't need all those tubes. Sometimes they have different buffers for different conditions. So basically, like, don't panic. Often they also come with like water, and you don't need that or something. So various things like that. So don't freak out if you don't use every tube, but make sure that you know what every tube is for. Make sure you know why you're adding what you're adding. In addition to just being really interesting, it also helps if you need to troubleshoot. Like maybe your reaction didn't work. Well, what component could have been messed up, or that sort of thing? What might you need to optimize? So basically, it's always good to know what you're doing, even when you're working from a kit. And yeah, treat them with care. Keep them on ice. Once you've finished with, like adding them, then go put your reaction at the temperature it's supposed to be at, and then go put your enzyme back in the -20 or the -80, wherever it's supposed to be. Put it in its nice home. Keep it nice and happy. If you do these things, your enzyme should last long time, probably longer than they say it should. But yeah, and hopefully your reactions go really well as well, and hope this was helpful as you start working with enzymes or continue working with enzymes, but I'm trying to work better with enzymes. I don't know. So keep them on ice. Don't vortex. Finger flicking stuff's good. Make the master mix. Avoid the small volumes and lots of tiny little pipetting, and yeah, have fun.